So we have a couple examples here of sigma notation. We're going to write out the first couple terms. Again, let's make sure that we are consistent with writing out at least three terms, so that we can tell whether the series is arithmetic or geometric or neither. So in this case, each term is 7 times the k value, which in this case is incrementing from 1 to 3, and we subtract 5, and then that pattern continues. 7 minus 5 is 2, 14 minus 5 is 9, 21 minus 5 is 16, and that carries on for a certain number. 2 plus 9 plus 16, so 2 plus 7 is 9, plus 9 is, or plus 7 is 16 again. So that's arithmetic. That's great. First term is 2, common difference is 7, number of terms is 8 minus 1 plus 1 is 8, and what we're doing is we're heading to the sum 8 formula. Again, if you use the sum formula where we don't know the last term in this case, so we have 8 times 2 by 2 plus 7 times 8 minus 1 all over 2. 8 divided by 2 is 4, 2 times 2 is 4, and 7 times 7 is 49. And what we end up with is sum 8 equals 212. Why don't you hit pause here and try the second example. If we write out the first couple terms in the second example, and we're getting a little bit more involved here. The first term is 324, negative 1 to the, this should be, f down here. F equals 2 minus 2 is 0. Then 324, negative 1, 3 minus 2 would be 1, and it looks like that's incrementing by 1, so negative a third squared, etc. 324, negative 1/3 to the power 0 is just 1, so our first term here is 324. 324 times negative 1/3 is 108, but it's negative style. 324 times 1/9, a positive 1/9, is 36. And let's see here, is it arithmetic? 324 to 108, 108 to 36, no, not quite the case. Dividing by 3 though, so yes, it is geometric. Term 1 is 324. Common ratio is negative 1/3. We can pick that off, or we can take a look at the original sigma notation. And the number of terms, 10 minus 2 plus 1. 10 minus 2 is 8 plus 1 is 9. So we have 9 terms in this series. So S sub 9 is term 1, 1 minus a negative third to the power 9 over 1 minus a negative third. Let me change that 1 to a 3/3, seeing as we're going to have common fractions here, common denominators. 324, that's 4/3 on the denominator. Negative 1/3 raised to the power 9 is negative. 1 minus a negative should be plus, and that works out to be 1.00005, etc., etc., etc. I'm carrying that in my calculator. That decimal times 324 divided by 4/3 gives me a rounded 243.0123, etc., etc., etc. So that's sum 9. Example 3, we have writing a series in sigma notation, so we need to identify if it's arithmetic or geometric. I wouldn't give you one which isn't one of those two. Negative 6 to negative 1 is us adding 5. Negative 1 to 4 is again adding 5. So this does look like it's arithmetic. The last term is 49, but let's write down on the side here what we know. We know term 1 is negative 6. We know the common difference is 5. I don't know how many terms there are, but we do know that t sub n is 49. So what we need to use is we need to use the t sub n formula. Tn is t1 plus dn minus 1. to figure out how many terms there are in this series. Let's see, 49 negative 6 plus 5 to the n minus 1. Adding 6, we get 55 equals 5 n minus 1. If we divide by 5, we get 11 is n minus 1. Adding 1, we get 12. So there's 12 terms. Sigma notation for arithmetic is fairly straightforward. We're just going to start with j equals 1 up to n, which is 12. The first term is negative 6 plus 5 to the j minus 1. So certainly arithmetic. The example 4, write in standard sigma notation, negative 3, 6, negative 12 up to negative 768. If we take a look at this, it would appear to be geometric, because multiply negative 3 times negative 2, we get positive 6 times negative 2 is negative 12. Why don't you hit pause here and see if you can write the standard sigma notation for this one. So, term 1 is negative 3, common ratio is negative 2. The n number we don't know, but t sub n is negative 768. So let's go to the formula for a geometric term. T1r to the n minus 1. Negative 768 is negative 3, negative 2 to the n minus 1. Dividing by negative 3, we get 256. Negative 2 to the n minus 1. So we're looking for 256 as a power of 2. So we're going to need to, or in this case, negative 2. So we're going to assume that the power has to be an even number because it needs to become positive. If we use some sort of Goldilocks in the 3-bear method here, guess and check if we will, we could try an 8. Negative 2 to the power 8, if you punch that in your calculator, is 256. So 8 is n minus 1 when we compare the exponents, and n has to be 9. So sigma notation of this series, because it does stop, it is a finite series, stopping at 9, is term 1, which is negative 3, common ratio of negative 2 to the j minus 1. And there we have the sigma notation for this geometric series. This ends the examples and notes for sequences and series for Pre-Calculus Math 11 special unit sigma notation.